name is Alejandro, and welcome back for day 149 of me doing the Daily LeetCode challenge until I reach 1 year's worth of green contributions here on GitHub. So today's problem is for December 12, 2024. Let's get straight into it. Okay, today we get LeetCode easy. Problem 2558, take gifts from the richest pile. You're given an integer array gifts, ooh, Christmassy, denoting the number of gifts in various piles. In every second, you do the following. Choose the pile with the maximum number of gifts, okay? If there's more than one pile with the maximum number of gifts, choose any. Leave behind the floor of the square root of the number of gifts in the pile. Take the rest of the gifts. Return the number of gifts remaining after k seconds. Okay, so we're just going to use the heap for this, right? So here's like, okay, you take the 100, the first second, the last pile is chosen, 10 gifts are left behind. Wait, so choose any, yeah, okay. Leave behind the floor of the square root of the number of gifts in the pile. Take the rest of the gifts. So yeah, 10 are left behind. Okay, so we can just do a min heap is equal to, so we can do heap q.heapify gifts, and then we'll say for in range k, and length of gifts is at least 1. Okay, good. Then we'll say, hey, max gifts is equal to heap q.heap_hop from gifts, right? And here we'll say res is equal to 0. And then here it's like leave behind equals math.floor of math.square root of the max gifts. We'll do res plus or equal to max gifts minus leave behind, and a heap q.heap push gifts, we're going to do a leave behind, and then return res. So this would be my idea. Does this work? It does not work. Okay, what is this? Oh, and I got a 3. No, this is good, this is good. So here we'll just do print f string max gifts, or max gift. Yeah, so let's just do max gifts becomes max, actually, yeah, okay. Here we'll do, we'll change this to max pile. All right, so max pile heap q.heap_hop from get, which we've heapified. Oh, we're doing a min heap. Map lambda num to negative num of all of gifts. Yeah, so we need to use a max heap, right? Max heap. Max heap equals list of map of lambda num colon negative num of gifts, right? Then we put the max heap, and then here we'll do this max heap. And so yeah, gifts, we can turn this into a max heap, right? And this will become max heap, right? So something like this should actually we need to do negative here. There we go. And here we still get a, oh my goodness. Max pile equals leave behind equals max heap equals. Actually, yeah, we need to do negative leave behind, right? And so now does this work? No. Wait, okay, so we've done, we multiply every number by negative 1. Then we heapify this thing. We do max is equal to negative heap q.heap_hop from the max heap. Leave behind, yeah. Max pile minus leave behind. And then, yeah. This should work. Okay, so let's see what's going on. What's up? Max heap equals. So here we have 64, 9, 4, 25. So yeah, we got 100, which is good. Leave behind is equal to 10. The last pile is chosen and 10 gifts are left behind. Wait, do I not understand the problem? Oh, do you get rid? Wait, choose a pile with a maximum number of gifts. If there's more than one pile, oh yeah. Leave behind the floor the square root of number of gifts in the pile. But then take the rest of the gifts. Does this not mean that that's the gifts you get? Or like... Why is it 29? Is it 10 plus 8? That's 18. 23, 26... What? This is just poorly worded. Wait, what? The first second, the last pile, so this one is chosen, and 10 gifts are left behind. There's no 10 in here. What the heck? What is this problem asking? Then the second pile is chosen and 8 gifts are left behind. This guy's square root is 8. Is chosen. Oh. So is it res plus or equal to leave behind? Essentially? And then this is negative max pile minus leave behind. This is just so, I don't understand the wording of this problem. This problem is so wordly weird. I don't understand what it's asking. And the second pile is chosen, so this becomes an 8. So it's saying, like, you have 25, this becomes an 8. Then you have 9, 4, and 10. So this is chosen, and then you have a 5. Okay, and so then it's just this. Okay, so that's what they're asking. And then what is this? 5 plus, okay, so 10 plus, so 8 plus 4 is 12, plus 10 is 22, plus 9 is, this is way more than 29. What the heck? Am I dumb? Oh no, this becomes a 3. Okay, that becomes a 3. So here this is 7, 15, 15, 20, 29. Okay, so that's what they want. Okay, I get it now. I understand it now. All right. Heap queue. What they want is this. They want us to do this. Leave behind is that. They want us to not do this. What they want is for us to put back leave behind, and then at the end return sum of max heap. This is what they want. No? Oh, yeah. We have all the numbers as negative. So we could just multiply the result by -1. Okay, there we go. Okay, sorry. It's just this is a hard problem to understand. But there we go. A completion streak 149 days. Consistency is key. See you tomorrow. Okay, so yeah, that was just the wording was a little tricky there, where I was just not understanding what the problem was asking. But yeah, okay, I understood it at the end. Having an example really helps. Is there anything I can do a bit more efficiently? Well, yeah, I'm just using a max heap. Do I need to put a list here maybe? Yeah, that's fine. Maybe if I do negative gift for gift in gift, negative gift pile for gift pile in gifts, right? So let's see, does that happen to be a little bit faster is what I want to ask. Maybe a little. So 3ms, 4ms, okay, it's essentially the very same thing, right? So essentially we're just, you know, simulating a max heap via a min heap, everything negative, this and so on. Okay, so as always in all my videos I do a quick recap of how I was able to solve the problem. So for this one, honestly, the hardest part of the problem was just understanding what the heck the problem is asking, right? Here, essentially, like I saw, you know, you're given a bunch of gifts, and each time, you know, choose the pile with the maximum number of gifts, you're going to modify some value and so on. Okay, this is an absolutely perfect problem for a heap, right? It's like, you know, always take, you know, whatever's the biggest, do something to it, add it back to the heap so that you can take whatever's biggest then and so on, even with the new modified values, etc., 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 right? So this is exactly what I did. The only thing that I did was, that's maybe a little tricky, is that I simulate a max heap via min heap in Python. So in Python, you have this heap queue library, which, you know, supports a bunch of methods like, you know, heapify to heapify a list in O of n time, or, you know, heap push to push something to the heap in O of log n time, heap pop to pop, you know, the maximal or always the minimum element inside the heap in O of log n time. And so essentially, if you have a list like, you know, 1, 2, 3 here, with a min heap, you always pop the smallest. So in this case, you pop a 1 in this array, right? But if you multiply everything by -1, what used to be the biggest is now the smallest, and what is now the smallest used to be the smallest is now the biggest, right? So for example, 1 used to be the smallest, but now it's the biggest. -1 is bigger than -2 and -3. 3 used to be the biggest, but now it's the smallest. So that way, when you pop the smallest from this, because Python's implementation of heaps is a min heap, you pop this -3 here, which you can then remultiply by -1, and there you go. You just simulated a max heap where you popped in log n time the maximum element inside of the heap, right? So that's essentially why, you know, I multiply everything by -1. Whenever I pop from the heap, I multiply by -1. Whenever I add stuff to the heap, I multiply by -1. When I get the sum of the stuff in the heap, I multiply it by -1. And that's why I'm putting all these negatives in there, because again, I'm just simulating a max heap via min heap in Python, right? But otherwise, all this problem is asking you is like, hey, you know, always choose the pile with the maximum number of gifts, which if we have a max heap, we could just, you know, pop in log n time, you know, that maximal value. If there's more than one pile with the maximum number of gifts, choose any. Good, because we'll just, you know, always pick the one, even if there's a tie that is the largest with a heap. And leave behind the floor the square root of the number of gifts in the pile. Take the rest of the gifts, right? So it's like, you know, I guess so this was why it was weirdly worded for me, because I thought, like, you know, this is the result. I guess what they mean is you take the rest of the gifts and you leave 10, and at the end you want to know how many gifts were left, right? And so that's essentially what they're asking you. So it's like, okay, basically you replace this value with you know, the floor of the square root, right? So essentially what I do is and we do this every second for a maximum of k seconds. So then we return the number of gifts after k seconds, right? So here's just, I initialize my max heap, you know, I set it as, you know, gifts, but I do the negative gift pile for every single gift pile in gifts, which is like, you know, gifts is, you know, each element is essentially, you know, the number of gifts in that pile. So like 25 gifts in this pile, 64 in this pile, 100 in this pile, 9 in this pile, and 4 in this pile. So I multiply everything by -1 so that, again, I can do that simulation. Then I do heap q.heapify max heap, so which is an O of n operation. This is why heaps are so powerful, because heapifying a heap so that, you know, you can push and pop in log n time only takes O of n time. It does not take O of n log n time. Obviously, popping everything from a heap after doing that O of n thing will take, you know, n operations, each taking log n time, so it's n log n. So you effectively get the same thing as a sorted list. It's just that, like, if you need to stop after some k, it's better than just sorting a list and, you know, doing the first k kind of a thing. Okay, and in this problem, you know, sorting doesn't even help that much. A heap is absolutely perfect. So here it's like, okay, we're going to traverse k seconds. So, you know, for a for loop that iterates k time, what we're going to do is we're just going to, you know, pop the maximum element from the heap, which we're just going to multiply by -1, because, again, everything is negative because we're really using a min heap under the hood. Then it's like, okay, we're going to compute that leave behind value, which is, they tell us, needs to be the floor of the square root of the number. So here we have the number, which is, you know, this max pile. Then we're going to math that square root that number, and whatever value that gives us, we're going to math that floor that number, right? So essentially we take the floor of the square root of that number, and then it's like, okay, we need to put that back into the heap, right? Because that's going to be a new remaining pile of gifts. All the other ones are discarded or like, taken with us. And obviously, since again, we're simulating a max heap via min heap, we need to remultiply that by -1 so that, it gets put in negative, so that we always have negative values in the heap, so that, when we pop the minimum element, we're effectively popping the actual maximum element, and there you go. And then at the end, what they say is like, after you've done all the k operations, you should have, how many gifts are remaining per pile, and, return to me the sum of those, right? So here I just return the sum of the max heap, but again, every single number is multiplied by -1 on purpose, so I'm just going to add them all together, which is going to give me the negative of the result, so I multiply by -1, and there you go, bada bing, bada boom. That's how I was able to solve the problem. So very straightforward, and like once you understand the problem, it's very, very straightforward. It's just, grab a heap, use a max heap, and just keep popping the maximum element from the heap, convert it into the floor, the square root of that number, push it back into the heap, and then just keep doing this k times, and then just return the sum of the remaining gift files, and there you go. Bada bing, bada boom. That is how you solve the problem. So otherwise, that's pretty much it for this video, and I hope that solution made sense, but otherwise, I will catch you in the next one. So until then, ciao, ciao, my friend. Bye-bye.